Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 15 on the 2008 Pascal paper. In the diagram, what is the perimeter of triangle PQR? Okay. So, what do we do here? Well, we've got QR over here. It's 25. I can get PR. It's going to be 8 plus 20, so 28. But I don't know PQ. And we kind of need that in order to figure out the perimeter. So what can we do? Well, my eyes wandered to this S and this right angle we've got here. I'm thinking we might use Pythagorean triangles. The Pythagorean Theorem. 25 and 20. We can square 25, subtract the square of 20, and get the square of QS, and then use that. We'll get another right angle, get QP. It's always a good idea to have sort of a plan of attack. I probably could put the triangle down in the bottom corner there, but let's give 15 its own page. It's about that time in the contest where things start getting their own pages. Not like the first few questions where you can fit 4 or 5 of them on a single page. Alright, so we got our right angles there, 25, 20, and 8. Alright, so what does the Pythagorean theorem tell me? Well, we got a right angle here at S, so that tells me that QR squared is SR squared plus SQ squared. Well, that's 25 squared is 20 squared plus, I don't know what SQ squared, or SQ is, so I don't know how to square it. But if I rearrange, I can say SQ squared is 25 squared minus 20 squared. And if you have your calculator handy, feel free to expand them out. 625 minus 400. Additionally, you might have done a lot of these contests, and you might be very familiar with the Pythagorean triples that we have here. And so you might be comfortable being able to just sort of jump to 15 here. Or at the very least be able to say, well, I know 25 squared, and I know 20 squared. I have these squares memorized to a certain extent. But we get SQ squared is 225, and if you want to hit the square root button, you'll see that SQ is indeed 15. Now, how was I able to write that without having finished off my calculations? Well, I could have calculated it really quickly in my head, but more importantly, there are some right angle triangles that come up a lot. The 3, 4, 5 triangle is a very popular one, and this one is just a similar triangle to that. Everything's been multiplied by 5. So as soon as I realize, oh, 25 is 5 times 5, and 20 is 4 times 5, the remaining side is going to have to be 3 times 5. So there are some other popular ones. The 5, 12, 13 triangle is incredibly popular. Now, a slightly less popular one is the 8, 15, 17 triangle. I know one contest creator for the Pascal who really, really likes this triangle, but other than that, it's not the most common one. So if you recognize, ooh, we've got 8 and 15 here, you're going to get 17. That's really nice, and if you know your Pythagorean triples well enough, this is a great example of a question where you will be able to go through it very, very quickly. But if you aren't able to make those jumps, that's okay. We can just do another Pythagorean theorem application, and we'll get PQ squared. The thing we want is QS squared plus PS squared, and we'll get 15 squared plus 8 squared. In fact, you don't even need to write down this 15, because we just use QS squared from before, so you don't have to simplify the 225. Or you don't have to simplify square root of 225, because you're just going to use 225 a little later anyway. So 225, 64, and that adds up to 289, and that's something you do have to recognize as the square of 17. Alright, but we're not done. We want the actual answer to the question, so 17 plus 28, that's the total of PR, plus 25 is, that should be 70, I think. Yeah, because 28 is 25 plus 3, 2 25s is 50. The remaining 3 goes with the 17 to become 20, so we should get an answer of 70. Do we have an answer of 70? Yes, we do. It's right there. It's E. All right. So that's question number 15. Join me in the next video for question number 16. Until then, have yourself a wonderful day.